Imagine you are managing a busy construction site, and you've just hired a crew of incredibly fast robots. They lay bricks so quickly that an entire house goes up in an hour. But there is a catch. These robots do not have common sense. They follow instructions perfectly, to the absolute letter. If your blueprint is vague, or if you ask for a house without explicitly mentioning the doors, you will end up staring at a solid brick box with no way to get inside. Modern software development operates exactly like this. The AI coding assistants available today are that lightning-fast construction crew. Because the AI handles the physical typing of the code at incredible speed, the human developer's time is shifting. The hours once spent typing out every line of code by hand are being replaced by a different kind of work. To succeed today, you have to evolve from a bricklayer into a master architect and a strict building inspector. To do that, you need a new way of organizing your work, a system designed specifically to manage your robotic crew. The first rule of this new workflow is that preparation is everything. Because the AI builds almost instantly, the human developer spends the majority of their time making sure they know exactly what needs to be built before the first robot starts. This starts in the research phase. You use automated tools to pull in a massive amount of raw signals, gathering user feedback, data sources, and the precise context of what the software needs to achieve. Raw information can be chaotic. As this diagram shows, scattered data points and documents are funneled down into a single, highly organized structure, a second brain, or a wiki. This lets you see the big picture without getting lost. With your research tightly organized, you enter the planning phase to draft the AI's master blueprint. This living digital document, called a state file, serves as a dynamic map, tracking long-term goals and pinpointing your exact current progress. Keeping this map flawlessly updated keeps your automated crew on track. It identifies structural errors before the AI writes a single line of code. Once the building starts, you face a logistical challenge. If the AI writes 1,000 lines of code in seconds, you cannot realistically read every single line to verify it followed the plan. The solution is automated verification. You essentially hire a deeply cynical, grumpy building inspector for the job site who trusts absolutely no one. Every time you assign a task, it must include strict boundaries and an automated test. Before the AI even begins, the test defaults to a failing state. The task is only complete when the AI successfully forces that test to pass. Using a guilty until proven innocent testing framework ensures mistakes don't pile up. It is the only safe way to manage the massive amount of code a robot can generate. As the project grows, you might have several robots working on different parts of the house at once. If one robot tries to install plumbing while another is still moving a wall, they will eventually conflict and break the build. You manage this through sources of truth. Think of these as the site manager's master clipboards. They ensure every worker is reading from the same set of instructions. The first clipboard is your code repository. This acts as the physical storage lot where the actual finished building materials live. The second clipboard holds your project management trackers. These contain the highly specific, bite-sized daily to-do lists that you feed directly to the individual AI agents. The third clipboard is that master blueprint from earlier, the state file. It updates constantly to ensure that no worker ever loses track of the global project goals. When these clipboards sync automatically after every completed task, the risk of robots clashing disappears. This allows the developer to stay focused on the high-level architecture rather than manually coordinating every small move. Software development has become an exercise in high-level system design. As this footage of a synchronized factory floor shows, the goal is to create a process where every moving part knows its place. This process rests on 4 pillars: intensive research gathering, a living blueprint, strict testing that defaults to failing, and trackers that stay in sync. This system compounds over time. Every time the AI solves a tricky bug, that knowledge is captured into the system's memory, making the next build even more efficient. By setting up these rules, you are constructing a repeatable, high-speed system where your own standards guide every move. You are no longer just making an app. You are building the factory that builds the app.